an example together and kind of go through how to solve this. We'll follow all these steps, we'll use the equation, and I'll kind of show you how to work through an example like this. So a roller coaster with a mass of 0.5 kilograms begins at rest at the top of a 4-meter hill. It then travels down through the valley back up to the top of a 3.5-meter hill, but does not necessarily stop, so don't assume it stops at the end. How fast is the coaster going? At the top of the 3.5-meter hill. So here's my roller coaster diagram. So here's my roller coaster. Not that any of you know that song, but it's an excellent song. Okay. And then I'm going to draw, so here's my roller coaster cart. It's got a mass of 0.5. Here's my first hill. It's 4 meters above the ground. Here's my second hill. It's 3.5 meters above the ground. So I drew a diagram. I need to label my initial and final. So my initial I usually call A, but you can write it as I if you want, if that makes more sense. And my final is B. So it talks about starting at the top of a 4-meter hill and ending at the top of a 3.5-meter hill. So that's why I'm making A and B, those two spots. But again, you can call them initial and final if you want. This is just how I've done it. Okay. Then I need to label where H is 0. Well, the place that makes the most sense to do that is the ground. So just write H equals 0 on the ground. So then we're ready to do our knowns and unknowns. So the height at A is 4 meters above the ground. The height at B is 3.5 meters above the ground. The mass is 0.5, sorry. The initial velocity, it says it starts at rest. So the initial velocity, or the velocity at A, however you want to write it, is 0. And the velocity at B, we want to solve for. How fast is it going? There. Okay? I'll give you a minute to catch up because I'm going kind of fast. All right, so now that we've got everything labeled, we're ready to do the equation. And the equation we're going to use is this. Kinetic energy initial plus potential energy initial equals kinetic energy final plus potential energy final. So in order to do this, we need to find those values. So I'm going to write them, just like we did with the potential energy, off to the side here. I'm going to find them all. So the kinetic energy initial is going to be the kinetic at A. So that's 1/2 mv squared. 1/2 mv squared, which is 0. The velocity at A is 0, so the initial kinetic energy is 0. Okay, easy enough. Potential energy at A, so the initial potential energy is mgh, so 0.5 times 9.8 times 4. So when I plug those in and solve, half of 9.8 is 4.9. 4.9 times 4 is 19.6. Okay, once I've found that, now I'm ready to do my final values. So my kinetic energy final is going to be the kinetic energy at B. So 1/2 mv squared. I don't know what the velocity there is, so I'm just writing v. So that's 0.25 v squared. And the potential energy final at B, mgh, 0.5 times 9.8 times 3.5. Which is 17.15. So far we haven't done anything new, really, that you haven't done in the last unit, right? We drew a diagram. We labeled the knowns and unknowns. We found all these individual energy values. Last unit we found the individual momentum values, but now we're finding energy. And now we're ready to put them in. So KEI is 0 plus PEI is 19.6 equals KEF 0.25 V squared plus PEF 17.15. So we subtract the 17.15 to both sides. Gives me 2.45 equals 0.25 V squared. I'm going to divide both sides by 0.25. Gives me 9.8 equals V squared. I'm going to square root 9.8 to get V by itself. And I get V equals 3.13 meters per second. Okay? Any questions on how I got that? Any place where I lost you, confused you, need to go slower? Any questions on anything? Yes, ma'am. You add the kinetic and potential initial together, and you add the potential and kinetic final together. So you don't add kinetic initial, kinetic final, potential initial. That's the potential final. So KE final is 0.25 V squared. PE final is 17.15. So when I set up the equation, KEF plus PEF, 0.25 V squared plus 17.15. Why is it V squared? It's this equation here, 1/2 mv squared, the kinetic energy. So it's V squared because we don't know what V is, and the equation tells us to square it. Huh? Yes, that's what we're finding. Yep. Yep. All right. But there's another way to do this.